Right. My name is Angelo. I'm here to present to you the ExtremePort QSFP DD112 connector, which we'll be launching. So going forward, I belong to a organization called within Amphenol called High Speed Connectors IO, or HSIO for short. We have a number of offices, and we were formed around 25 years ago, starting with the SFP form factor. We have a number of diverse like locations, as I mentioned. I'm personally located out in Toronto, Canada, but we have primary manufacturing facilities in Shenzhen, China, as well as Bangalore, India. And together we make up this global team to support our products worldwide. Um, so speaking more about our products, as I mentioned, we've been started quite a bit of time ago. As a result, we have a portfolio to boot. So things really kicked off around 5 years ago with the explosion of AI and demanding faster and faster connectors. We're forced to develop connectors which are challenged between everything between space and thermal requirements, which a reason for why we developed so many of these product lines. Um, OSFP, which was only started in the 2020s, for example, has really been taken off alongside its variants. But today we're concerned of the ExtremePort QSFP DD, or QDD for short, which is the 112G connector of the QSFD form factor. So that's highlighted in yellow there. So just some basic information about the form factor. It's basically a SFP connector, but with 8 channels or 8 lanes per port. That's 8 times the density of the SFP form factor. And we're able to deliver up to speeds of 112 gigabits per second using PAM4 signaling. And together, 8 times 112 is roughly around 1.6 terabits per second, which is the aggregate bandwidth speed that this connector can deliver. So um, we're using a number of applications. So it's pretty diverse as our portfolio suggests. We can be used in testing equipment and high-speed communications such as switches, routers, and in telecom scenarios. But the biggest one that's been kind of forcing our demand for this faster QSFP-DD product is datacom. So this is used anywhere between supercomputers to AI accelerators to even graphical processing units. And unfortunately, I wasn't able to get a closer look into the pictures that we use for this particular product but I've also included a number of switches from the exterior, which are sold by our customers. So just to begin off with the QSFP-DD connector, this connector has been out around 5 years or so ago. We started off with this connector originally designed for 50 gigabits per second PAM4. So in total, that's 400 gigabytes per second of aggregated bandwidth. Um, this is, like as I said, QSFP-DD is a form factor which squeezes 4 times 2. DD standing for double density. QSFP is actually another form factor, and we just took the existing form factor and then lengthened it to accommodate the same type of module. So in essence, it has the same details as the QSFP on the front. So that's 0.8 millimeter contact pitch. So as long as your paddle card meets that contact, you should be able to plug it in, as well as 56 per contacts per port. So um, as you can see, there's a row of connectors or paddle cards on the front, and as a 2 pairs in the back, kind of. So in total, there's 4 wafers being used in this connector. So in total, you have 76 pins or 76 positions per port. This is all defined within the MSA, which is the multi-source agreement. It's an agreement that our competitors, as well as some of our customers, come together and define this connector. So as I mentioned, it's backwards compatible with QSFP modules. This really promotes the legacy applications and versatility of the connector. We support both passive copper and optical solutions, like cabling solutions that plug into the connector. Um, we can also support quite a bit of power with this module. So we're seeing for the previous 12 to 15 watts per module, which um, is quite a significant amount of heat. And especially, we're also seeing 20 plus watts. So we have a number of heatsink and thermal solutions that are designed to meet this increased power. So far, we also have a number of configurations. So on the right side, in the middle, we have the one by one cage and single SMT connector. This is for the ones that are just single port, which is the most common type of configuration. We also support 2x1 stacked cage and connector. So they use a different type of cage and connector altogether from the single, and they can support the same amount of or a number same amount of ports and a greater density. So here on below, there's the configurations that are available. So we have everything from 1x1 to 1x5, as well as 2x1 to 2x2. So when we say 1x1, we're talking about one row and one column wide. So 1x5, that'd be one row and 5 columns wide, which is a ganged configuration. And so where we're at today is now the QSFP-DD 112G. So that's exact same connector, but with the increased speed from 50 gigabits per second. We have it both in 1x(n) SMT and also 2x(n) SMT. For purposes of today, I'm only going to be speaking about that 1x(n) configuration. So in a 1x(n) configuration, we are using 1x1 SMT connectors. So each single port now supports up to 800 gigabits per second aggregate per port. So as I mentioned earlier, that's 8 times 112. This is designed for optimized performance, SI performance, and high volume manufacturability. So we introduced a number of new features to the QSFP DD connector. So that includes the laser welded wave shield to minimize crosstalk and row-to-row crosstalk. So we also change a lot about the signal pathing. So we minimize the amount of use of plastic, especially in the front. You can see that the open area in the front, you can see a little element of the wave shield coming above the wafers, which helps shield some SI for the connector. We also changed up on the copper alloy used to ensure the normal force and tighter impedance control through the mating interface. And the good thing about this all is that we can use the same SMT connector with the old QSFP-DD cages that we've continued to sell and support. As of right now, the 112 connector is in mass production. So we're producing tons of it, and it's completely supported today. We have all the supporting documentation, including SI models, and all the application specs and data sheets you need for it. As I mentioned, we can use the same cages. So everything that's available for the QSFP-DD regular connector or 50G connector is available for this 112 variant as well. So that's 1x1 to 1x5. We also have various heat sinks and light pipes available. So as I mentioned, we in order to address like the different thermal and power requirements, we have various heat sinks that vary in height and as well in length, as well as light pipes for any LED applications on the board. So, speaking a little bit more technical about the connector, here's the data sheet available actually online for our 1x1 112 connector. So, you can see a number of options as indicated by the part number configurator. We have this is how it looks like from the bottom view. Um, we also have a number of options, including packaging, Mylar options, plating options, and I'll speak that more about that in greater detail. And if anyone wants me to share about this directly, please feel free to contact me after this webinar. So, as I mentioned, we have a lot of part numbers, and it gets a bit confusing what to choose and what's the most common or recommended. Luckily for you guys, we have two recommended part numbers. We have the connector available in standard mounting, as shown in the middle picture here, as well as the one on the right side, which is the one with the solder rings. Um, so both of them use the same type of plating, which is the 76 micrometers of gold on the mating interface, as well as uh, the same packaging type, which is the regular 32 millimeter packaging. The difference between the standard mounting and the solder rings is standard mounting is designed to use for single-sided applications, so where the connector is always right side up. Solar rings gives a little bit of a better adhesion to the board, so you can solder those two pegs in the front of the connector for belly-to-belly applications. This is for any applications that you need to place it below the board or overhanging the board. Um, in all details, they come with Mylar tape on the front of the wave shield as standard. And this is recommended for 99% of all applications. Here's a little bit more of the footprint, and I get a lot of questions asking about more about the footprint in particular about between this connector and the old one. So luckily for you, we haven't changed too much because they use the same cage. All the cage footprints and locations are the exact same as previous. The only difference is the pin pads. So in order to control the increased speed and tolerances, impedance tolerances we need with this faster speed, we decrease the size of the pin pads. And the same locations are denoted with the pin pads. So if you have existing boards or any applications, you can actually really easily modify that board to accommodate for this connector. The width the width and the length of the connector is exact same as before. So all the solder positions and the peg and vias, they're exact same. The only, like I said, the only difference is the pin pads that would need some modification. Furthermore, we have the SI performance for the connector, which is a hot topic with this increased split piece speed. We have greater challenges with um, SI. We've, like I said, we implemented a bunch of features to get that SI the same level as before. And here's some of our specs that I'll roughly go about. So for the nearsided differential pairs, we have the tolerance here. So it's a little confusing if you don't have to be an SI expert. But if you look at the tables on the center and also on the right, the table in the center, the higher the number, the lower the lower the reflection of the differential pairs. So that's a better number. Conversely, the right side table shows the noise, the near and far end crosstalk. So in this case, the lower the number on the right side table, the better the performance with against crosstalk is. So we have these specifications that are defined as agreement between our competitors, and we're well within and exceed that as MSA defined spec. Um, a lot of questions about routing and layout with this new connector. we have all the documentation available. So feel free to reach out to me if you have any concerns or any specific guidance with your application or customer about with this connector. Um, yeah, so that concludes the presentation on that on the connectors. And yeah, I'll open the floor to any questions.
Thank you, Angelo. I do have a couple questions for you. Are there any other variants of the new QSFP-DD 112G connector?
Yeah, so as I mentioned, we have the 1x1 and the 2x1. We're excited to release the 2x1 for general distribution soon. We have it available for both the 56G as well as the 112G. As I mentioned on the customer drawing, you can see a number of options ranging from anywhere from the mating plating to the packaging, even the packaging type. So those two numbers that were recommended are the ones available for general distribution. But if on special requests, we can accommodate really any combination formed with that in that part configurator. It really depends up to your application.
Thank you, Angelo. And do you have the QSFP-DD single cages press fit available with the two rear legs in stock?
Yeah, we do have the press fit. So press fit is actually designed for 56G speeds. And if you're talking about the cages, all our cages are press fit, with special circumstances for the solder cages, but 99% of all our cages are press fit with, and they're available with the single pin. We got the dual pins as well. Um, as for like our neck connectors, we only have the press fit available for um, on the tails, the SMT tails, or in this case, the press fit tails for the 56G. For 112G, it's all the connectors are going forward are SMT or surface mounted.
Thank you, Angelo. And can you explain more about the methods you are using to thermally support the increased power brought by the connector?
Yeah, so the connector has a number of heatsink options. So this ranges from traditional fin type heatsinks that you see. We have more complex zipped fin heatsinks. These are a little bit more costlier and fancier. They are using different types of surface area and a range of like lengths and features such as side wings extended from the cages to kind of give the increased surface area for that heat dissipation. We also have a number of thermal interface material, or TIM for short, which are special coating placed on the heat sinks to kind of help the thermal contact and lower the thermal resistance between the module and the heat sink. This is really neat technology, and we have sampling available if you're interested. They're not standard for our cages that we sell, but can be requested on special requests. Um, so we have a number of generations. We work with Henkel as in their partnership with their technology in that. Um, Also, we have a number of liquid cooling solutions that we are developing. This is more so for the ganged or stacked ganged configurations, which have a lot of thermal challenges. If you might have attended an event with our demo, we would have had the demo with this, as well as like we have it available for the OSFP for low quantity samplings, and we would continue to kind of gauge the interest on that liquid cooling if our applications need be.
Thank
I
you,
also
Angela. Oh,
oh
sorry, go
yeah,
ahead.
I also see a question about someone asking, do you have cages with fans?
Mhm.
Unfortunately, no. All our current offerings are passive cooling. So we have only the air-cooled stuff and the thermal stuff. With any fan application, we can help accommodate based on custom design. So if you have a certain wind direction or um, air pockets that you need to meet or space requirements, we help kind of design a passive solution to accommodate that fan design. But no, we don't have any pre-existing fan designs.
Hmm. Thank you. And I do have another question for you. What is the fate for existing QSFP-DD connectors?
Yeah, so the 56 or 50G connector is continuing to be supported. That's not going to go anywhere soon. We're continuing to improve it with design modifications, with PCNs. We're going to continue to sell it and become in mass production. Uh, we just offer like a newer model, the variant of that, which will be continuing to be supported as well. We're also gonna, like I mentioned, release the 112G connector soon for distribution for the 2x1 configuration, I'm sorry, which will introduce a number of interesting products and special cages to accommodate them. And as for the future of the connector itself, we have the 224G in development. So in this special connector, it's actually double the amount of speed we're currently launching at the moment at 112. So that's in total 1.6 terabits per second aggregate with a single connector. That's a lot of speed crammed within the QSFP form factor. And we are developing it, so it's only available in low sample quantities at the moment. But any interest, please feel free to reach out, and we're continuing to develop and fine-tune this connector in order to kind of meet the same performance as our 112 connector.
That's great. Thank you, Angelo. And that is all that we have for you today. If you have any questions, please do not hesitate to reach out. And I want to say thank you to everyone for joining us, and we hope you enjoyed today's presentation with Angelo and Matt.